Hi guys, this is Bill, obviously. What I did here is I switched out the plasma tubed arrangement with the neon transformer and I switched over to line voltages. What I did is I took an old heater, that's the coil and the heater fan, and the idea of the fan is to help kind of cool the coil. It's not really necessary, but I had it and I put it on. And it's AC, but the resistor part of it, or the coil, is DC. We got a full-wave bridge rectifier right there on a heatsink, and then a 1600 microfarad capacitor operating at 450 volts DC. From there it comes through, so it's DC, and I have two electrodes. In this case, this is the positive one, and that's the negative. And with DC, the positive electrode erodes faster than the negative does, because of the way the charges interact. But what I did is I had, you see down below here, you know, this down here, where my finger is, that's the torch, and when I light the hydrogen it comes up through the arc. That's the whole idea here, is I was trying to excite it more, or see what I could do with it. The voltage at the electrodes is around 184 volts, open circuit voltage, otherwise not running. So it probably drops down to about 160 or something like that. You know, take the DC component and times it by 0.707 or something like that and come up with corrected voltage. Or is that AC? Anyway, maybe that's AC. You guys are smarter than me, can tell me that. But other than that, everything's the same. But I did disconnect from the filter, and I'm running it straight from the cell. And the reason I did that is because I was having problems seeing the hydrogen Balmer lines with the spectrometer. So I wanted that sodium hydroxide mist or vapor that comes out with the gas to be there so I could see it on the spectrometer easily, and it worked out very well. So at any rate, yeah, it's very temporary, kind of proof of concept, just to get an idea of what I want to do here, and then I'll build an actual safe unit, because right now it's everything's hanging out here, and a guy who wasn't careful, you get knocked on your butt. Anyway, I got a box basically to emit some of the light and shield it, so I'm not getting directly hit by it. And this hole here is where the light emits through and it comes over to the spectrometer, which is there. That's the lens cover is on it right now. But anyway, that's how it works then. Of course, you saw the other video how I had that set up. So, kind of give you an idea. It's if you guys decide to do this, be very, very careful, because the line load on this, when I first start the carbon arc, it's around 14 amps. So you do the numbers, 168 volts times 14 amps, will definitely mess up your day. So be very, very careful if you guys decide to work this. And keep in mind that one arm behind the back if you happen to be working on something. And something else that I noticed is after I shut down, or the electrodes burn back and they lose their continuity, otherwise stop arcing, I take a screwdriver that has a well-insulated handle, and I lay across the electrodes. Let me grab I'll kind of show you what I'm talking about. You can see the screwdriver tip here, and I'll lay it either across like this to short out the capacitor, because the capacitor will hold that charge, you know, 160 or 180 volts. Because after the arc stops, the voltage climbs up to 184 volts in this particular setup. So you don't want to get tangled up with that. So be sure to short it out, and one hand or in your pocket or behind your back, and only use one hand so you don't take a chance of getting a shock through your body, because this would stop your heart. So you guys, if you do it, be careful. I would probably recommend, if you don't have any experience with this type of a thing, you probably should avoid it, because it can definitely mess up your day. And you might want to let somebody know, if you are working with it, that you're out in your shop area, to come check on you, make sure everything's all right, or have somebody here with you standing back in case you get shocked and your heart stops. They can get you resuscitated and get you back kicking. So just a little safety to keep in mind. Yeah, this I'm rambling. That's that fluorescent light that I use to take Spectra off of. Also, I use that for reference. And what I'm doing is I'm looking at the carbon arc right now, baselining the Spectra on it for reference points. So when I introduce the hydrogen, I'll have 2 reference points to measure from to get accurate readings on the hydrogen lines from the base lines of unexcitement up to whatever they happen to go to. So anyway, that's it. I'm rambling. I'll shut up, and I'll see you guys on the rebound, and hopefully with more information from there. Talk to you later.